You ever wonder how Netflix just knows what you want to watch next? Or how your bank can flag a weird transaction, literally seconds after it happens? Well, a lot of the time, the secret ingredient is a piece of technology called Apache Spark. It's a name that gets thrown around all the time in the big data world, but what is it really? Well, in this explainer, we're going to pull back the curtain on Spark and see exactly why it's such a massive deal. So what's all the hype about? It really boils down to this one kind of shocking number, 100 times. For some specific jobs, especially the kind you see in machine learning, where you're hammering away at the same data over and over, Spark can be up to 100 times faster than the technology that came before it, Hadoop MapReduce. And let me be clear, this isn't a small improvement. This is a complete and total leap forward. 100 times faster? I mean, that sounds less like engineering and more like magic, right? But it's not. It's actually the result of some incredibly clever thinking and a totally fresh approach to handling data. So the big question is, how on earth did they do it? Let's break it down. All right, so before we can get into the nuts and bolts of how Spark is so fast, we need to get on the same page about what it actually is. So let's start with the basics. Okay, at its core, Spark is a unified analytics engine. Now that word unified is everything. See, before Spark came along, if you wanted to do different kinds of data jobs, you needed a bunch of different tools. You'd have one for basic queries, another for live streaming data, and a whole separate one for machine learning. It was a mess. Spark basically said, nope, we're putting all of that into one single, powerful system. And for developers, that was an absolute game changer. So now that we know what it is, let's get to the really juicy stuff. How does it get that unbelievable speed? We're about to dive into Spark's secret sauce. This right here, this is the single biggest reason for Spark's speed. The old way of doing things, with systems like Hadoop MapReduce, was just painfully slow. It had to write everything back to a physical hard drive after every single step. Imagine you're baking, and after you crack an egg, you have to put everything back in the fridge. Then you take it out, add flour, and put it all back in the fridge again. It's nuts! Spark, on the other hand, keeps everything out on the countertop, right in the computer's super-fast memory, or RAM. We call this in-memory computing. And because RAM is ridiculously faster than a disk drive, you just blow past that old bottleneck. The difference is truly night and day. Okay, so how do you manage all this work across, say, hundreds of different computers? Well, Spark uses a classic setup called a master worker architecture. The analogy here is perfect. You've got the driver program. That's the brain. It's like the architect who looks at your instructions and draws up the master blueprint for the entire job. Then you have the executors. Those are the muscles. They're like the construction crew, spread out across all the machines, doing the actual heavy lifting on their piece of the data, all perfectly coordinated by the brain. And this is where things get really, really clever. Spark uses something called a DAG scheduler. Now, DAG stands for Directed Acyclic Graph, but don't worry about that. Just think of it as a super smart GPS for your data job. Before a single thing runs, the DAG scheduler looks at the entire journey your data needs to take and calculates the absolute fastest, most efficient route possible. This pre-planning avoids so much wasted effort and is a massive part of what makes Spark so efficient. So how does it pull off that clever planning? Through a brilliant concept called lazy evaluation. Basically, Spark is the ultimate procrastinator, but in a good way. You can give it a whole chain of commands. We call them transformations, like filter this, sort that, group this, and Spark does nothing. It's lazy. It just sits back and uses those instructions to build out that perfect optimized roadmap, that DAG we just talked about. It's only when you finally say, okay, show me the answer, which is called an action, that Spark finally springs to life and executes the entire plan all at once in the most efficient way possible. Okay, so we've talked about speed, and that's a huge piece of the puzzle. But it's only half the story. Spark's other superpower is just how incredibly versatile it is. This is way more than just a fast engine. It's the whole data toolkit. Just look at this ecosystem. It all sits on top of Spark Core. That's the main engine room. But then you get all these specialized libraries you can plug in. You've got Spark SQL, which lets business analysts run the same SQL queries they already know and love. That's huge. Spark Streaming is for handling data that's pouring in live, like from a social media feed. Then there's MLlib, a fantastic library packed with machine learning algorithms for building things like recommendation engines. And GraphX is for analyzing networks, like figuring out connections in a social graph. But here's the real magic. You can mix and match all of these in a single program. You could be analyzing live data with streaming and immediately run a machine learning prediction on it with MLlib. Trying to do that before Spark was an absolute nightmare. This is all really cool technology, but what does it actually mean out there in the real world? Where does the rubber meet the road? Let's take a look. The short answer is just about everywhere. When your bank sends you that text about a suspicious charge moments after it happens, that's often Spark churning through data in real time. Those product recommendations you see online that are just a little too perfect? Yep, that's Spark crunching through your data. From healthcare companies predicting patient needs to media giants optimizing your video stream, Spark is the invisible engine behind so many of the services we rely on every single day. And this isn't some niche tool for a few tech giants. The adoption of Spark has been absolutely staggering. Today, over 80% of Fortune 500 companies use Spark for their big data processing. It has truly become the industry standard. This slide really says it all. When you put Spark side by side with the old school tech, Hadoop MapReduce, it's not even a fair fight. It's not just that Spark is faster, it's a totally different beast. It's unified, it's way easier for modern programmers to use, it's incredibly versatile. It was simply built for the kind of data challenges we face today. It wasn't just an update, it was a true paradigm shift. So, what's the big takeaway here? Spark became dominant because it's the Swiss Army knife of big data. It's that one single tool that can handle almost any job you throw at it, whether it's old batch data, live streaming data, or complex machine learning, and it does it all with incredible speed. That combination of raw power and amazing flexibility is what made it a force of nature in analytics. So Spark was this revolutionary thing that completely redefined what was possible, right? It solved the biggest problems of its time. But technology, as we know, never ever stands still. The amount of data in the world is just exploding, which means new bottlenecks and new challenges are always right around the corner. Which leaves us with a pretty exciting question. What will be the next great leap forward? What will the Spark of the next generation look like?